All right, so today we'll be looking at Senior 2 chemistry, and we'll be concentrating on our 5th unit, which is hardness of water. So we know that water can be classified into two categories. We have hard water and then soft water. The soft water is that water that makes lather easily with soap. And the examples of that are rainwater, distilled water, deionized water. Most of that is just soft water. Now, the hard water is that water that does not form lather readily with soap, and examples include tap water, seawater, borehole water, well water, spring water, and many other types of water. Okay, when you put these two types of water in glass, you always see that the soft water is more transparent than the hard water. Hard water contains a lot of the dissolved minerals and things like that, while the soft water doesn't, so it is more transparent. There's no organic material to make it not to be transparent. Okay. So I hope, Elizabeth, you are following. And we can look at the causes of hardness of water. We have things like calcium ions. Okay. Try to highlight this. Calcium ions are key in causing hardness of water. Magnesium ions. Okay. Once these ions dissolve in water, these salts cause the water to be hard. Okay. So the source of calcium and magnesium are dissolved by rainwater and carried into water bodies, the springs, the lakes, the oceans. And the compounds that cause hardness of water include calcium hydrogen carbonate. So this is a calcium compound, which we call calcium hydrogen carbonate. We have magnesium hydrogen carbonate right there. We have calcium chloride, which is a salt also, and magnesium chloride. We also have calcium sulfate and magnesium sulfate. All these compounds cause hardness of water. Okay. So when you ask what causes hardness of water, just mention these compounds, the calcium compounds and magnesium compounds. Well, we have their sulfates, we have their chlorides, and then their hydrogen carbonates, and then their hydrogen, yes, mostly their hydrogen carbonates. Okay, so their chlorides, their sulfates, and their hydrogen carbonates cause the hardness of water. Okay, so that's good. If you have a question, Elizabeth, you can always type it in the chat box. Let's look at the effects of magnesium and calcium ions on soap. So soap is made up of sodium salt of a long chain carboxylic acid. Elizabeth, do you know what a carboxylic acid is? Do you know what the carboxylic acid is? Let me see. Okay, you say no. So it is a weak acid, just like, any other acids. But this acid contains hydrogen and carbon and oxygen. So those are the elements found in carboxylic acid. It's like an acid of a carbonate. Okay, that's how you can sort of take it. An acid of a carbonate. So this salt here that makes up soap is known as sodium stearate. Okay, most times we can abbreviate it. We can abbreviate sodium stearate right here. factor right there. Sodium and then St. Soap reacts with magnesium or calcium ions to form dirty white solids. These solids, we call them, this term here, scum. So when the sodium stearate reacts with the magnesium and calcium ions, they form scum. That is the dirty substance, dirty white solids. That is the scum. So when hard water is used for washing, a lot of soap is used because part of the soap initially reacts with calcium and magnesium ions to form scum. Okay, so that's what happens when you're using hard water. You're going to use a lot of soap because part of the soap is going into reacting with those ions instead of going straight into reacting with the dirt and removing the dirt from your clothes or something. Instead, part of the soap is reacting with the water itself that you're using. Now that is not good. That is not helping in the process that you're trying to do. Okay. Here is an equation for this. We have, for example, calcium sulfate reacting with sodium stearate to form sodium sulfate and calcium stearate. Okay, this is just a displacement reaction. Right there. Okay. So yeah, that is the effects of magnesium and calcium ions on soap. Okay. This is why if you use borehole water or spring water or lake water, you always use a lot of soap. Now you know the reasoning behind that. I hope now you can explain it to your people at home why soap goes so much when you use hard water instead of soft water. Okay. Any questions so far? Elizabeth, if you have questions, you can always type them in the chat box. Let's look at the types of hard water. There are two types of hard water, permanent and temporary hard water. When you talk about temporary hard water, it's a type of hard water whose hardness can be removed by boiling. The water can be made soft by boiling. This type of hard water is caused by the presence of dissolved calcium hydrogen carbonate or magnesium hydrogen carbonate. So when you boil it, it becomes soft. Can't see the equation clearly. Oh, you want to see the equation? Okay, the equation is right here. And if you have a question on it, you can always ask. All right. So the two compounds that cause temporary hardness are calcium hydrogen carbonate or magnesium hydrogen carbonate. All right, so once any of those is dissolving in water, that water is temporarily hard. Boiling, it becomes soft. And permanent hardness is a type of hard water whose hardness cannot be removed by boiling. The hard water cannot become soft on boiling. So therefore, for it is permanently hard. Even if you boil it a million times, it won't become soft water. It is caused by calcium sulfate, calcium chloride, magnesium sulfate, or magnesium chloride. So these are the compounds that make permanent hard water. Once these are dissolved in water, water becomes permanently hard. There's nothing you can do about it to make it soft. So that is very, very key to remember. Okay. Now with that, if you don't have any questions, let's watch a video about permanent hardness. Did you hear that? I'm wondering if I shared my sound. Let me just check. Okay, now I'm sure.
Hardness. It is the hardness caused by the presence of chlorides and sulfates of Ca2+, Mg2+, and Fe2+. It can be removed by treatment with washing soda or sodium carbonate. Sodium carbonates converts calcium and magnesium salts to insoluble carbonates which can be filtered off. Calgon's method. It is sodium hexametaphosphate. The complex anion keeps the Mg2+ and Ca2+ ions in solution.
So, like you've seen, when the water is permanently hard, it contains those huge complexes that cannot be turned into soft water, even on boiling. Okay, those type of complexes are not really in temporary hard water. This is why when you boil it, it immediately becomes soft.
Hardness.
Okay, let me first remove this. All right. Cool. So do you have any questions here? Do you have any questions so far?
Of water. In this module, you will learn about
Elizabeth, do you have any questions here? Okay, if you don't have any questions, we can continue with the distinguishing of permanent hard water from temporary hard water. Okay. Now, for you to carry out such an experiment, here is a procedure. Place equal volumes of each unboiled water samples in 3 different conical flasks. Run soap solution from the burette into each sample while shaking the conical flask until when leather is formed. Note the volume of soap solution required to form leather with each of the unboiled water. Results: the soft water required the least volume of soap solution to form leather compared to samples of hard water. Repeat the above procedure with boiled water sample. Here are the results. Soft water required the same volume of soap solution to form leather in the unboiled water or unboiled soft water. Temporary hard water after boiling required less volume of soap solution to form leather than the unboiled one. This is because the water was made soft by boiling and thus formed leather readily. Permanent hard water, even after boiling, required the same volume of water of soap solution as the unboiled to form leather. This is because even after boiling, the water still remained hard and took time to form leather. So this shows you that even if you boil permanent hard water, it still requires a lot of soap for it to form leather. Okay, meaning even if you boil it, it doesn't become soft. Okay, let's look at the methods of softening water. The first one is what you've been mentioning, the boiling, which is a physical method. And what happens in boiling? Boiling decomposes calcium and magnesium hydrogen carbonates to their respective carbonates, water and carbon dioxide gas. The calcium and magnesium ions are removed from the water as insoluble calcium and magnesium carbonates. The calcium and magnesium carbonates may be deposited as solids at the bottom of the boiler and are referred to as boiler scales of kettle fire. So what happens is the salts, magnesium hydrogen carbonate and calcium hydrogen carbonates, once you boil them, they decompose into their carbonates. So if it was calcium hydrogen carbonate, it could decomposes into calcium carbonate. Also carbon dioxide and water are produced. Now this calcium carbonate is insoluble, so it settles at the bottom of the boiler, which is at the bottom of this, for example, on this picture, or on the sides, around the sides. So that these ones are removed, okay? Once they are removed, now we don't have the compounds that make it hard water, meaning it has become now soft water, okay? So that's what happens. Now the disadvantages of boiler scale fire, or that coating of the salts that are eliminated. The fire produced is an insulator, hence a lot of heat is required for boiling, and this wastes a lot of fuel. The fire produced may also block pipes carrying boiled water and possibly causing it to, I think I missed a word there. So it may this may cause pipes to block or to burst when that fire is formed in those pipes transferring the boiled water. By chemical means, the fire can be removed from the kettle by adding mineral acids like hydrochloric acid and sulfuric acid. So yeah, when these chemicals are stuck, for example, at the bottom of this boiler, you just have to add an acid to remove them. Okay. Another way to make water soft is addition of calcium hydroxide or lime water. This is called the chemical method. Calcium hydroxide reacts with the soluble magnesium and calcium hydrogen carbonates to form soluble magnesium and calcium carbonates. Just like you see in this equation, calcium hydrogen carbonate reacts with calcium hydroxide to form calcium carbonate and water. The disadvantage of this method is that when excess lime is used, the water becomes hard again. So you have to use moderate lime. It has an advantage in that it is cheaper than boiling, as calcium hydroxide is readily available. The other way we can make water soft is addition of aqueous ammonia or ammonium hydroxide solution. This is also a chemical method. During this process, a soluble hydrogen carbonate are converted into insoluble carbonates. This enables magnesium and calcium ions to be removed from the water. So again, ammonium hydroxide reacts with any of those salts, whether hydrogen, calcium hydrogen carbonate or magnesium hydrogen carbonate, to form their carbonate, their respective carbonate. This is a solid, insoluble. So these ones can be removed. They can settle down at the bottom of a container or on the sides. Okay, then you can also form ammonium carbonate and water. These do not really make any changes. Methods for softening both temporary and permanent hardness. We have distillation. It's a physical method. Distillation involves making sure that you heat the water, it evaporates, and then it's collected. The minerals and those other dissolved salts are left as residue in a flask here. Okay, so you heat, this is your hard water, heat it. Pure water evaporates at 100 degrees Celsius, and then it settles down in this beaker here, conical flask. That leaves the dissolved residues in here at the bottom of the flask which you use to heat. That's the physical method. We have a chemical method here, add the additional sodium carbonate solution or washing soda. This is a chemical method. Sodium carbonate converts magnesium or calcium ions into insoluble salts. For example, when you add sodium carbonate to calcium hydrogen carbonate, you form sodium hydrogen carbonate, which is soluble, and calcium carbonate, which is a solid, is insoluble. So this one, after it is formed, you can eliminate the calcium ions. Okay, they get settled at the bottom or on the sides, and then you remove them. We also have the ion exchange method or permeate it. So it's a chemical method. The calcium ions and magnesium ions in the hard water can be exchanged with sodium ions using a soluble ion exchanger material. This makes the water to become soft. So once you remove those ions, that really make water hard. That is the rationale behind all these methods. It's just removing those two ions, especially calcium and magnesium ions. Once they are removed, the water becomes soft. So this is what is happening here in the ion exchanger. This one works by removing ions, the magnesium ions and the calcium ions. Okay. Lastly, but not least, we can look at the advantages of hard water. Calcium compounds in water are important in our diet for strong teeth and bones. Magnesium in water is important for photosynthesis since it is used for formation of chlorophyll. Calcium in hard water is responsible for the formation of strong cells of many animals, e.g. snails and eggs. Water tastes better hard water tastes better and it is used in brewing industry. Hard water reduces lead poisoning and it is the only type of water transported by lead pipes. Okay, so those are the advantages of hard water. The disadvantages are it wastes a lot of soap. When hard water is used for washing, it leaves dirty marks on clothes. I don't know if you have encountered that, but when you use hard water, you leave marks, yellowish marks on white clothes and other types of clothes. Hard water forms kettle fur and boiler scales. Most containers are destroyed like that, or boilers. The boiler scales may block the pipes carrying boiling water, hence causing pipes to burst. Okay. So it's important to remember that. All right, let me play this video so that once you watch this video that is being streamed right now, you can complete the lesson. Okay, so I'm gonna go ahead and play this, our last video, and then we'll finish the lesson. Okay.
If you wash with soap using rainwater, washing is easy and there are plenty of bubbles. We say the water is soft. But if you use well or tap water, it's sometimes difficult to get a lather and the scum forms. In this case, we say the water is hard. Hardness is usually caused by the presence of calcium ions dissolved in the water. Water coming from rivers or wells has had to flow through the surrounding rocks, and if they contain soluble calcium salts, the water will become hard. So here's a question. Why do you think rainwater is always soft? pause the video until you have thought of an answer. Well, all the salts which dissolve out of the rocks end up in the seas, but when water evaporates, later forming the rain, the salts are left behind in the seas, meaning that the rainwater is always free of salts and therefore soft. However, gases from the air can dissolve in rainwater, and one of these is dissolved carbon dioxide. When rainwater falls on limestone, that's calcium carbonate, the limestone dissolves slowly, which is how the great caves full of stalactites are formed. Here is the equation. Calcium carbonate reacts with the carbon dioxide in the rain to form soluble calcium hydrogen carbonate. This form of hardness is called temporary hardness because boiling reverses the reaction and the hardness is removed. But the limestone will deposit in your pipes, on the cooking utensils, or in your kettle, forming something we call lime scale. And this is also how stalactites are formed in those big caves. Another form of hardness is called permanent hardness, which comes from rocks containing gypsum, which is calcium sulfate. In this case, you do not get lime scale, but you still, of course, get a scum with soap. So what is this scum? Well, soap is made by boiling natural fats and oils with sodium hydroxide. The soap molecules, for example sodium stearate, have a long tail which is attracted to oil or dirt, and the sodium ion end which is attracted to water. In this way, dirt is lifted off your hand and the clothes and is carried away by the water. However, calcium stearate is insoluble, so if the water contains calcium ions, the soap will not work until all the calcium ions have been precipitated out as scum. Detergents are sodium salts of compounds called alkyl benzene sulfonates, whose calcium salts are soluble, so there is no problem of scum with detergents. So to summarize, we saw that water becomes hard by flowing through rocks containing calcium salts, and these react with soap to form a scum of calcium stearate, making it difficult to use the soap. Temporary hard water forms deposits of lime scale when heated, but rainwater is soft, lathers easily with soap since it's free of dissolved salts.
Okay, so this video really did a great job in summarizing what we have looked at today. So please make sure you watch this live stream, and once you're done watching it, please go do these assignments. Okay, I have an assignment here. Do it and submit. Okay, thank you so much for watching. I will see you very, very soon.